So let's talk about what we found with our different modeled listener variants for pronoun interpretation in these different contexts. And so if we look at 3-year-old behavior, 3-year-old pronoun interpretation behavior is best captured by children having inaccurate representations. That's the score that's closest to 0, which is better under the Bayesian information criterion, or BIC, right? So they're going to have inaccurate representations, but accurate deployment, that using all the information they have, but sort of skewing that information. And what's interesting is, all 3 inaccurate variants are actually far better than the baseline that has both accurate representations and accurate deployment. But among the inaccurate variants, it's the inaccurate representation that is the winner for 3-year-olds. And the same pattern actually holds for 4-year-olds and 5-year-olds as well, right? The inaccurate representations are the best among the inaccurate variants, but of course all the inaccurate variants are better than the baseline. Now for adults, we see a different pattern, as it were. Adult pronoun interpretation behavior is best captured by the model that has both inaccurate representations and inaccurate deployment, right? Now, like the child models, all the inaccurate variants are far better than the baseline, but within that, the both inaccurate one is definitely the best, right? So there's, it seems to be the clear winner in the case of adult behavior. So again, which is what this says. I should have waited till my slide changed, but within the inaccurate variants, the both inaccurate variant is much better than the other two, right? So the takeaway from this is that both child and adult pronoun interpretation behavior are captured by modeled listeners that are inaccurate in some way, right? In fact, in the adult's case, inaccurate in both ways, right? So what this means is that becoming adult-like with pronoun interpretation doesn't mean becoming more accurate, right, in the sense of accurately representing the input distributions and accurately deploying, i.e. deploying all the information that you have available. It doesn't mean that, right? But what does it mean? Well, it means learning to become inaccurate in adult-like ways, right? And so that's what has to change, not the fact that you are inaccurate. That actually stays the same. What changes is the way that you are inaccurate. In particular, you go from, for example, having just inaccurate representations to having inaccurate representations and inaccurately deploying those representations, right? That's just one sort of big difference. So we know that adults inaccurately deploy their representations, while children don't seem to, at least under the best model fit. Okay, so we can look at the beta values, the use values, to see which information is being ignored and how often it's being ignored, because that's what children are going to have to learn. Now, we can also look at the sigma values, the contrast values, to see how the inaccurate representations are inaccurate. So are they too smooth with sigmas less than 1, or too sharp with sigmas greater than 1, or both? Like, what's going on there, right? What does that look like between children and adults? Is it the same or is it different? So let's look first here. All children, of course, are going to be best represented by accurate deployment, even though they have inaccurate representations. So that's equivalent to always paying attention to all information. So all our betas are always going to be 1, right? Fantastic. So now let's look at what adults are doing. So adults, it seems, are best fit by a model variant that pays much more attention to the prior over possible antecedents and agreement morphology, like 80 or 98% of the time, and kind of ignores pronoun form and connective information much more often, right? So you're sort of strategically ignoring form and connective and paying much more attention to morphology, say, among the cues. So becoming adult-like, it means learning how much to ignore certain information. And so again, just generally the pronoun form and connective you ignore more often. Sometimes you even ignore agreement morphology, and occasionally you might even ignore the prior, right? But you're selectively ignoring information. You're selectively paying attention to other information. That's what it means to be an adult. So what about the representations? Both child and adult representations are inaccurate, but how are they inaccurate? Let's look at what the best fitting values are that capture child versus adult behavior. Well, for child representations, the sigma values are often much less than 1. In fact, the highest one in this configuration here is 0.23. Most of them are kind of like at the lower edge, that 0.01 range, right? So what they're doing when they're less than 1 is they're smoothing away the probability differences that exist in the input signal. They're turning down the contrast and smoothing it away, right? And just to show you what this looks like, if we have a true probability of 0.75 versus 0.25, a sigma of 0.23 smooths that down to 0.56 versus 0.44. A sigma of 0.10 smooths that down to 0.53 versus 0.47, and a sigma of 0.01 smooths it down to like 0.502 to 0.498, right? Like really, you're kind of getting rid of everything, right? And so adults, however, are doing something a little different. Now they are doing the same extreme smoothing for the prior, right? The prior information. But for the cues, adults are substantially sharpening those likelihood probabilities in this case, right? With sigmas of 3 and 4. Again, 4 is actually at the edge of this range, right? So if we just show you what that looks like, 0.75 versus 0.25 is our true probability. With a sigma of 3, we sharpen this to 0.96 versus 0.04. With a sigma of 4, it's 0.99 versus 0.01, right? So I mean, it's really, you're really just kind of almost making it categorical in how you're using this stuff. So becoming adult-like is that children need to learn to sharpen certain perceived representations rather than smooth away the differences in probability that they perceive.